In this example, we're going to use the half angle formulas. We have a half angle formula for the sine, cosine, tangent, and notice that now we're referring to half of the given angle. And here are the equations. We have an example here where it says find the exact value of the sine of 105. This should look familiar to you because we used this same example when we were doing the sum and difference formulas for sine, cosine, and tangent. In that case, when we were doing sum and difference formulas, we would take this angle and we would split it into a sum or a difference of two angles whose exact values we knew. So in this example, I can break 105 up into 45 plus 60. But we're not doing sum and difference formulas now. We're going to try and solve that same exact problem using half angle formulas. And it's really simple. What we do is we rewrite this expression as double this angle, which is 210, and we write it as half of that. Because 210 divided by 2 is 105 degrees still. Okay? And then once we have rewritten this as a half angle and use this formula here for the sine of the half angle, notice that it says plus minus and there's a square root. So let's go ahead and do that. We're going to say this is equal to plus minus the square root, and inside the square root I have a fraction. It says 1 minus cosine of u, so 1 minus cosine of u. Notice that this u is referencing this value here. Okay, so in our case, that value is 210. That's our u. So 210, and of course, we wouldn't be able to use 105 because we don't know the exact value of 105 degrees. We do know the exact value of 210 degrees. So, and that is divided over 2. And very important, this 2 is inside the radical value, okay, not outside the radical value. Okay, so let's try and figure this out. This would be the plus minus square root. Now we're going to have 1 minus, and we need to find the exact value of cosine of 210. So the cosine of 210 is negative square root of 3 over 2. Notice how I wrote the minus that's in the formula, and then in parentheses I wrote the negative value of that cosine 210. And everything will be divided by 2. So this will equal plus minus the square root of 1, which I can change into 2 halves because I see I have a fraction. The common denominator is 2, so I can multiply top and bottom by 2 to make this into halves also. So I would end up with 2 over 2, which is your 1, plus, because minus negative is the same thing as plus, square root of 3 over 2. And let me make this radical a little bit taller so that I can fit my denominator of 2. So that will equal plus minus the square root. I can write everything over 2, so that would be 2 plus the square root of 3 over 2, everything over 2. And I'm still inside the radical. Okay, so notice I have a fraction in the numerator and a fraction in the denominator. This 2 is over 1, technically. So I can rewrite this as plus minus the square root of the numerator, which is 2 plus the square root of 3, everything over 2, times the reciprocal of the denominator, which is 1 over 2. And now I can multiply numerator times numerator and denominator times denominator, which is going to give you plus minus the square root of 2 plus square root of 3 times 1. It's still 2 plus square root of 3. And 2 times 2, that'll give you 4. Now, this I can separate into individual radicals. I can have my numerator in its own radical, 2 plus the square root of 3, and I can write my denominator in its own radical, which is the square root of 4. And by doing this, I'm able to simplify the square root. In the denominator, I keep the one in the numerator, and the one in the denominator, I can just write the radical over 2. Notice this 2 now is not inside the radical like it was before. It's outside the radical once it turned into a 4. Now, this plus minus, it's not telling me clearly if the answer to this question is positive or negative, okay? And how do I determine? How do I choose if it's going to be positive or negative? Very easy. I have to choose the value that corresponds to the original angle. So the sine of the original angle, is that a positive value or is it a negative value? Well, 105 degrees is found in what quadrant? 105 degrees is found in this quadrant, second quadrant. Therefore, the sine in the second quadrant is positive. Therefore, my final answer is that the sine of 105 degrees is equal to square root is equal to the square root of 2 plus the square root of 3, everything over 2. That's my final answer. Okay, we'll do one more example. I'll see you in the next video.